All right, folks, it's Bass Action back in action here. In this video, we're going to look at a couple things. We're going to look at a bigger, deeper example for baryons. Then we're going to do a quick review of cofunctions, reciprocal functions, and a little bit of calculator work to prep us for some stuff later in this chapter, in our next chapter. All right, on our first example here, we've got a ship leaving the port of Miami at a bearing of north 80 degrees east. So when we go to draw that, and knowing that that angle is 80 degrees, and the angle has to be formed between the vertical and the horizontal, I'm going to draw this nice XY axis, and that angle, that 80 degrees, is going to be almost directly due east. So this angle right here is going to be our 80-degree bearing angle. It says that it's traveling at a speed of 16 miles an hour for 1 hour. So our initial leg of our trip is going to be 16 miles. Then it says that it's going to turn 90 degrees to the south. And eventually they won't all be 90 degrees. But for right now, this is a good just introduction. It's going to turn 90 degrees towards the south. And it's going to go for 2.5 hours. So we can quick calculate the length of that next leg. 2.5 hours at 16 miles an hour is going to get us at 40 miles. So this next leg is going to be longer, and we can definitely know and feel comfortable with the fact that it's going to cross our horizontal. So this is going to be a 40. And then we've got our nice 90-degree angle. So we're going to eventually need to find our bearings. And let's go ahead and find an angle in this triangle, just like we did before. Let's go ahead and find this angle because it'll at least help us fill in some other things. So our 40 is our opposite and our 16 is our adjacent. So just like before, opposite over adjacent, inverse tangent, 40 over 16 will tell us that this angle here inside the triangle is going to be 68 degrees. Then we can fill in the rest because our 3 angles should add to 180. So we can fill this angle in here is 32 degrees. Now the language on this next question is what makes these sometimes kind of challenging. So I wrote this one to be a little bit more difficult. We want to know the bearing this time from the ship to the port of Miami. So now we want to go from the ship, which means we're no longer going from that port. So we're going to draw in a new vertical. Anytime you're working a bearing question and you have a new from, it's good to draw in a new vertical. So I'm going to draw in this new vertical right here. And if I'm going from my ship to my port, I'm thinking of it in this direction. Now, that means that I ultimately want the bearing, of course, off the vertical. So I want to know this angle right here. Now, that one I haven't calculated, but if we go back to our geometry days and we go ahead and apply our idea of our alternate interior angles, what we can see is that the angle that we're wanting from the ship is the same angle that we just calculated, these nice alternate interior angles here. So this angle here is going to be 32 degrees. So instead of saying from the port to the ship and knowing we're going in a south direction, we can see that we're going to go in the north direction and towards the west. So we can fill in our bearing pretty easily without having to do any new math, just using our geometry. So now we're going to say north 32 degrees west. Then we can also try another scenario. Things are going to start off the same. So we're going to give ourselves our nice XY axis. The ship is going to this time be heading on a bearing that is south 80 degrees east. So we're going to still be on the east side, but we're going to be below the x-axis. So we're going to go ahead and draw our angle here because remember, this is the angle from the vertical that needs to be the 80 degrees. We're still going to say he's going to go 16 miles. The ship's now going to turn and is going to go 40 degrees to the south. And we're trying to figure out, did the ship cross the vertical this time? So when we go ahead and we complete our triangle, we're trying to understand, I'm going to go ahead and draw this angle. We want to know if this angle inside the triangle is more than 80. Now, logically, it's probably not going to be more than 80. And we know from the last problem that if we do our opposite over adjacent, with this as our perspective again, we're still going to have that same inverse tangent of 40 over 16. Those legs didn't flip on our perspective, so our angle inside the triangle is 68 degrees. So the bearing is going to be from the vertical and our path of travel. The angle that we're looking at then here is going to be the difference between the 80 and the 16, or 12. Now let's look and see how they want us to write it. This time they want us to go to the ship from the port, or I like to read them with the word from first. So this time I am going from the port, okay? So I am going to go from the port towards my ship, so I can, it's a little easier to read. I don't have to draw on a new vertical. So I'm going to go south 12 degrees to the east. Okay. Now let's take a look at just some quick calculator review. Most of this should be review. You can see already that I filled in a few things. Okay. At the bottom for our calculator work. So on this top part, what we did in the last sections is we were working with, last sections being our last chapter, we were working with our identities. But on those identities, our angles always matched. So these angles don't match, but what I would want to jump out to you is that the angles on each of these problems are complements. 63 and 27, ignore that minus for a second, are complementary. 80 and 10, 25 and 65, those are complements. That's a clue that we can use our complementary cofunctions. So on example 3 here, example 3a, the first thing that we're going to call our attention to is this cosine of a negative 27. Remember, since cosine is an even function, we can change that negative 27 to a positive 27. Now, using our complementary cofunctions, we can choose to change one of the angles to its complement. It doesn't matter which. I'm going to go ahead and keep the cosecant 63. And sorry about that, cosecant 63. I don't know why I wrote an extra S there. Cosecant 63. And then I'm going to change cosine to its cofunction, which would be sine, and then I'm going to change its angle to its complement, which would be 63. Now we can easily see how this problem is going to be simple. Okay, our cosecant 63 can be rewritten as 1 over sine 63 times, of course, sine 63 over 1 gives us a nice simplification to a 1. On the next one over, let's go over to the cosecant 80 minus tangent 10. This time I'm going to change the cosecant. So I'm going to change my cosecant to its cofunction. So cosecant becomes secant. I drop the prefix. I change the angle to its complement. And then I'm going to leave the tangent alone now that my angles match. And now this should jump out to you as a nice identity, and that should jump out as a nice Pythagorean identity of 1. Next problem. This one, logically, the best part to change would be the 70 because it's the one function that's different. So I'm going to keep the cotangent 20. I'm going to keep the cosine 20. And then on the next part, I'm going to change cosine to its cofunction, which is sine. I'm going to change 70 to its complement, which is 20. And now I can see that I have cotangent 20 plus cotangent 20. And that's going to simplify to a nice 2 cotangent 20. And that's the best that that'll clean up to, and that's okay. On the next one, it's not going to matter what we're going to change because we have even numbers of both of them. So I'm going to change the 65s. So I'm going to rewrite this sine as its cofunction, cosine. This 65 is its complement of 25. The next one, I'm going to change this cosine to a sine, because cosine and sine are cofunctions, 65 to 25. And now what I can see is that everything is going to nicely cancel, and I will just get, again, a nice 1. Okay, the last little bit is a little bit of practicing in your calculator, and I'm just going to show you how these would be rewritten, and then I'm going to let you guys practice with your calculators. What we need to remember is that our calculators cannot type in these reciprocal functions, cosecant, secant, and cotangent. So to type those in our calculators, knowing that these are degrees and we want a ratio, we need to rewrite this as the 1 over our sine 37. So when you type that in your calculator in degree mode, you should be able to get approximately 1.6616. Make sure you can get that. We're going to type in 1 over cosine 22 since secant won't work. And we're going to get 1.0785. And the last one, what I want you to notice is tangent and cotangent are both reciprocals and cofunctions. So you could rewrite this with the reciprocal, but you could also flip this from the cotangent to the tangent and the 81 to the 9. I would strongly encourage you to type both in and be able to see that in fact you do get the same answer for either one of these if you want to, no matter which one you wanted. The last little bit we're going to do, and I put these side by side because these are often confusing for each other. On the next example, example 5, we're trying to get an angle measure versus on example 4, we wanted a ratio. I know I want angle measures on example 5 because each time our inverse notation tells us that what follows is actually a ratio. So since we're going to be doing the inverse function, it means that when we type this in our calculator, what should follow should be a ratio. So the reciprocal of cosecant is sine, but I need to tell my calculator that I have an appropriate ratio for the sine. So I need to flip that ratio upside down. And you can see that I did that for both secant and then the tangent. So the directions that I've given here is I want us to write these as positive degrees. So when we type this in our calculator, for example, example 5, when I type this in my calculator is going to give me a negative angle in the 4th quadrant because it understands the restrictions that we've been working with. So when I type this in, I'm going to get a negative 25 degrees. Well, if I want a positive angle, I'm going to need to add 360 to that so I get the nice positive coterminal angle of 335 degrees. Cosine's not going to have any problem. When I type that inverse in my calculator, it's going to give me a nice angle in the 2nd quadrant, and that's what I would expect, and it's going to give me 104 degrees. Tangent, this tangent-cotangent problem and the last one kind of combines our two issues. The cotangent says that I want an angle in the 2nd quadrant, but my calculator is going to give me my angle in the 4th. So when I type it in the calculator, I'm going to get a negative 27 degrees. And since I need to move that to the 2nd quadrant, I'm going to add 180 to get a final answer of 153 degrees. And you've got to be really, really careful on cotangent calculator questions. Okay, so that's kind of a long video, I know, but it covered a lot of really important stuff and definitely some calculator issues that some of you guys might often struggle with.